So we are going to start with a new chapter today, student. Tuples are similar to lists, so that similarity is going to speed up things a lot, because many things which you have already done, you have already worked with in lists, those things are the same in tuples. Only difference is tuples immutability. So we are going to discuss these things, and let's start with today's class. Okay. So here we are with tuples. What are tuples? So just like lists, we have tuples which are also data types, and to be very specific, they are immutable data types. Okay. So immutable data type means you cannot change the items in place in case of tuples. Now, I would like to give you one difference between tuples and lists. So just look at this image very carefully. This is how internally actually lists and tuples are stored in the memory. So you can see over here we have a list instance, and this is a tuple instance. Okay, so in the list instance you have certain fields like which describe the object type, which object type it is whether it's a list, string, tuple, integer, and so on. Object reference count, it is something which is not required because it is handled at the physical level. And object size, here because it contains three elements, so object size is 3, allocated 3. So lists have a small pointer within object item field which points to this list object, which is actually a list of pointers, collection of pointers, and each of these pointers points to other items in the memory. So the thing which we used to represent in this way, give me every time I forget to take out my graphic tablet pen. So just like I used to tell you, like we have a list object, right? And it points to a memory location which contains pointers, and each of these pointers, they actually are pointers to locations containing other data. Like this is an integer data, a character data, a string type data. Understood. So this thing has been little refined and expanded over here. So the list object which we are talking about, that is actually this list object. This is your list object. So this is the list object which we are talking about, right? And here this object item has a pointer. This is a pointer which actually points to a memory location which contains this list object. Right, so list instance, and this or item is actually pointing to an object which is a list of pointers, and each of these pointers points to several other objects in the memory. So here this is an integer object. These are three integer objects, and you can see the value 1, 2, and 3 over here. Object type is integer. Whereas in case of tuples, you can see that we directly have, when we say that tuples directly store the values, tuple object, it directly stores the values 1, a, hello. Right, when we say this has been little refined to say that the object item field of the tuple instance, it directly points to, it contains references to different parts. Okay, it just contains these references over here, as you can see, references to different objects. Instead of having another level of pointers, it directly contains references or pointers to the objects. Okay, this is the reason for its immutability. Here the object item directly contains the list of pointers. Here object item field contains a pointer to a list of pointers. Right? So this is the difference between how lists are represented in the memory and how tuples are represented in the memory. So this we don't need to concern ourselves much with this, but you should know this fact. Okay. So tuples are immutable data types. That is, you cannot change the values or list of the tuple items in place, right? If you have to change any item within the tuple, you have to overall assign a new tuple object to the identifier. Like in case of lists, if I had a list L and it contained these values 1, 2, 3, I could have easily written L1 equals 5. This was correct in case of lists. But if I have a tuple which contains the same values and I try to write T1 equals 5, this will be wrong because individual item assignment is not allowed in tuples. Individual item assignment not allowed in tuples. Got it? So that is the reason why in tuples we cannot assign elements like this. If you want to change the value, you have to overall assign a new tuple like this. This is allowed because here you are totally assigning a new tuple object, right? So the tuple identifier which is created, the original object which is there in the memory. Okay, like earlier, I'm just going to represent it in this way. Earlier it had this object over here which contained 1, 2, 3. I'm not writing the internal actual representation here. The actual representation will mean that the object item field will directly contain references to these memory instances which contain integer values. Okay, so don't go by that right now. Don't get confused. Right now, I'm going to use the simple representation. The simple representation just to make things easy and convenient for us. Every time drawing that whole tuple object with everything, object reference, number of items allocated and all, this would make this will slow us down. Okay, so that's why I'm going to use this simple memory representation just to speed things up. Okay, so we have 1, 2, 3 written over here, and if I want to change it, I'll have to overall assign a new tuple containing the changed values. So this the previous link will be broken. Just like we used to do for integers, floating point numbers, complex numbers, strings. They all are immutable data types. List was the first change when we drifted from those simple data types. So list was mutable, where we could have easily just changed the pointer, made the pointer point to some other location. But here we cannot do that because we don't have two levels of pointers. We have only one level of pointer where it is not possible. It has been designed in this way, right? Fine. So this is the thing which we were discussing about. So now let's move on. How to create tuples. Now next is creating and accessing tuples. How can we create tuples? So there are a couple of ways which you can see here. Tuple with no member, empty tuple. So how can we create a tuple with no member? We will use a function named as tuple. Just like in case of lists where you used, can anybody tell me, just a question for everyone, can anybody tell me what is the function we use for creating a list? How can we create an empty list? One is by using a pair of empty square brackets. That is one answer. And the second one is a function which we use for creating lists. It is object.list function. So you don't have to use object.list function. It is simply you have to write list object equals list. That is, we use a list function for creating a list object. Let's see it. One way for creating lists is we use the list function. And the second one is we simply assign an empty pair of square brackets. This was for lists. Same way we have for tuples also. We have a tuple function which we use for creating an empty tuple, and otherwise also we can create an empty tuple by simply providing this empty this round pair of round brackets or parentheses. Okay, so this way we can create a tuple. So we will just see this over here. T equals tuple, and here if I print T, you can see a pair of empty round brackets, right? And if I write here T equals pair of empty brackets, that is also a tuple. Okay, but here you have to be very specific here. It is again, I have created a new object, new tuple object. This was a different tuple object created at some other memory location, and this is another tuple object, right? And hence these are two different tuple objects. So this is how we create an empty tuple. We can create, now we know that tuples are also such collections, they are also sequences. A list is also a sequence, right? That is, they are a collection of objects of different types, and same goes for lists as well. Lists are also collection of objects of different types. Yes, Aryan Kumar Baghel, very good question. What I did was earlier I used the same, as I told you that tuples don't provide individual list assignment. That's a different thing. If you are creating a tuple object using the tuple function, so I've created this. So in the memory, a separate tuple object is created. An empty tuple object is created with one box, you can see over here. When I, now this would be created at some memory location, maybe 1100, right? Next time when I did this, it created another memory object at some other memory location, and the previous association was broken here, and the tuple identifier now started pointing to this memory instance or this tuple instance. Right, tuple instance means a tuple object. So two different objects. This object also exists in the memory but at some other memory location. This object is created newly and this is created at some other memory location, and this tuple identifier is now pointing to this memory location. Same you can do with any data type also. You can do it with lists also. Like if I write L equals list, so this will create a list object, right? Fine. So this is a list object. Internally, it might be having two different levels of pointers. So I'm not drawing the internal representation for the sake of convenience here. Okay. So this could be at some other memory location. And later when I write L equals empty square brackets, it also creates an empty list somewhere else, and the list points to that memory location. That is because although lists are immutable objects, okay, but because here what am I doing? I am reassigning the list with a completely an entirely different list object. मैंने दोबारा से एक list बनाई है. Okay, I haven't written something like L1 equals so and so. ऐसा मैंने नहीं लिखा है. That is, I am not changing anything in place inside the original list. I have altogether just reassigned a list. So पहले जो list था, list object बना, अब वो memory में ही है. It is there in the memory, but it is unreferenced by any identifier. Instead, this identifier is now pointing to some other memory location containing another list object. Is this clear? So next is we can, what I was talking about, list contains elements. They are collection of objects of different types, just like lists. Sorry, tuples are collection of objects of different types, just like lists, right? Unlike strings, why? Because strings are only collection of string type objects, that is alphanumeric objects. Which alphanumeric, what are alphanumeric values or objects? Which are a collection which can be created out of the Python character set using digits, using uppercase letters, lowercase alphabets, uppercase alphabets, okay, using special symbols and all. So that is what a string. So that could be either, if you create a string, it could be either a string containing more than one characters, or it could be a string containing a single character also. They are also sequences, but they are collection of the same type of elements. Okay, but lists are a collection of different types of elements. Like I had said before, you can collectively store integers, float, complex, boolean, uh, other nested lists, tuples, dictionaries, I mean any type of data type within lists. So same goes with tuples also. Tuples are also a collection of objects of different types. So if I have a list, I got a question over here that can we convert list to tuples or vice versa? The answer is yes, we can do that. If I write here L1 equals 1, 2, 3, 4. So this is a list. I can create T1 out of this by using tuple L1. Now if I print T1, you will get a tuple. As you can see, there are pair of round brackets over here. Okay, and if I have a tuple T2 which contains these values, that is, it is a tuple containing first 5 alphabets of the English alphabet, and I can write here list2 equals list T2. Okay, and list2, now it is converted into list. So slowly and gradually we will be seeing various factors concerning ourselves with lists and tuple, students. Okay, be a little patient, right? Okay, so I'm going to create a tuple over here which contains different types of values. Like I'm creating a tuple, one tuple you have already seen over here. This is a tuple of characters. I'm creating another tuple which is a tuple containing integer values. So this is a tuple containing integer values. Okay, I can create a tuple containing mixed values. So you can see that this is a tuple containing mixed data types, mixed values, that is different values belonging to different data types, right? So we can create tuples just like we create lists. Two differences, tuples are immutable whereas lists are mutable, and that is visible by the brackets which we use. Lists use square brackets and tuples use round brackets, right? So this is tuples. Okay, so one question for everyone. I'm giving you all a question. Please note it down. Create a tuple containing the first 10 natural numbers. Create a tuple containing first 10 natural numbers. Let's try to do it using list comprehension. Like I write numbers here and I don't know whether it will work. So I'm just using the tuple function. Within this, I'm using a list comprehension. And let's see what is numbers. You can see that numbers is a, now this is not natural numbers, these are whole numbers because it starts from 0 over here, as I forgot to start it from 1. I ended it at 11 but I didn't start it from 1. So what I did in this statement is, just look very carefully. In this statement I have used a trick because I cannot use list comprehension. This type of a construct is actually list comprehension, which is used for creating lists. So what I did was I used a tuple function outside of it to convert the list, and then it will convert the list into a tuple and it will assign it to numbers. So now I have a tuple that is numbers which contains values from 0 to 10. Okay, one another simple question. Create a tuple containing colors of your choice. Yes, just look over here. What I did was I created a tuple from a string. This is the string programming. Okay, and I have used the tuple function here. What does this tuple function do? It converts, it breaks down each character. It breaks down the sequence by character and it creates a tuple out of every character of that string. So now every character of the string forms a tuple item. Same goes with list also. If you use the list function along with this programming, it will convert each character into a list item, just like this. Okay, so when I am converting any other sequence into tuple, or if I am converting any other sequence into list, at that time I need to specifically use the tuple and list function. But if I am creating a tuple only, at that time it's not wrong, but it is not required. Tuple to string, just wait. I haven't tried that. We'll do that. Suppose I have a tuple. So I'm having a tuple here and let me just write values. So I have a tuple containing these 4 strings and let me convert it into string. What it does is it just converts, it includes everything within the string. Okay, right from these brackets, they are also considered, each of these things is a separate character. This bracket, this single quotation mark, HELLO. Okay, if I just print the length of this string, my string, it is 33, consisting of each and every character. Only thing is, it's like this. If I write it using print, you will see that this whole thing, every character inside this is considered to be a part of the string. So converting tuples into strings is not effective unless and until you have a specific purpose for that. Got it? If you specifically want that in your project, you can definitely do that using the str function. But you have to be careful because it also converts the outer brackets. Same goes with lists also. Right? Okay. So tuples of integers and float, tuples of characters, tuples of strings. We can create tuples on almost any type of data. Somebody also send me something. Just check. Okay. So we can create tuples of any data type and also tuples of mixed type as well. And we can also create nested tuples, which we will see in a short while. So now empty tuple, everybody knows how to create. We use one is the tuple function which we use and another is the pair of empty parentheses. Next is a single element tuple. So just let's do this. A single element tuple, that is if I write t1 equals, now here I don't have anything specific, okay, so I am using t1 and t2 here. So I write t1 and I wanted to assign only one value in the tuple and I write it like this. If I print t1, it will not consider this as a tuple value. Just look at this very carefully. I'll explain this. You have written this statement, right? Now what you did was you said that okay, because I can create a tuple, if I can create a tuple like this, अगर हम ऐसा कर सकते हैं, so I can very well assign one element to the tuple using writing 4 within the brackets, okay. But when you do this kind of an assignment, Python doesn't consider this 4 as a tuple element, rather it considers it as its original data type, that is integer. Whatever you are giving, if you are writing t1 equals hello, so the data type of hello is what? String. So ultimately t1 will be allocated a string only. The data type of t1 is not tuple, it is, here it is integer, here it is string. Right? But if you want to create, you are still adamant on creating a tuple consisting of one element at least, you have to write it like this: t1 equals 4 comma. At least after the element you have to provide a comma. This is to show that this object, it is a tuple, right, which can contain more than one elements in the future. Okay, even if you wanted to store only one element, you have to give this comma over here, then only it will be recognized as a tuple. So if we just check it over here, I'm writing t2 equals 4 comma, and if I print t2, you will see it is a tuple. If I just use the type function on t2, you can see class tuple, and if I use the type function on t1, it is an integer, right? So this is the difference. So empty tuple and single element tuple which we have created. Next is long tuples. Now long tuples are similar to creating long lists. Like I told you, if there are a lot many elements in your tuple which might not fit inside your screen, so you can change the line also. Right? I write here T3 equals 1, 2, 3, 4, 5, and you think that after writing 10 elements, I should change the line. So you can very well do that. Right, and you can close the bracket and press enter, and when you type T3, it will be all in all elements on a single line. Then we have nested tuples. So what are nested tuples now? Just like nested lists we used to have. They are tuples within tuples. Right? So if I already have a tuple T equals, and I write here 4, 5, then I write here 6, 7, then I write here 8, 9, 10. Now let us identify the elements. Okay, this is 0, this is 1, 2. This will be considered as the third element because this is one single element, then 4, 5, and then this will be 6, and it will be considered as one single element. Within this, we will be having the individual I indexing of each of the elements within the tuple. So this is a tuple, this is a tuple, this is integer, integer, integer. So you can say that you have 5 integer objects and 2 tuple objects within this tuple. Got it? So these are nested tuples, that is tuples containing tuples, just like tuples containing lists. Sorry, just like lists containing lists. Now, tuples can also contain lists, lists can also contain tuples. So it will be like if I write here T1 equals, I write 1, 2, 3, and then within this I write 4, comma 5. So this is list within tuple. And if I write L1, I write here 1, 2, 3. 1 2, and then I write here 4 comma 5. So this is tuple within, I missed out 3 there, this is tuple within a list. So this also you can do easily, right? Then we have creating tuples from existing sequences. Okay, if we have sequences, using that we can easily create tuples, that is from strings and from lists. See, in computers, there is nothing which contains infinite values. When you talk about infinite, anything infinite or a list infinite, GP, general progression, so geometric progression in case of maths. Now, that you can represent on paper. You can represent infinity on paper, but that cannot be represented in computers because computers are digital uh, devices and which work on discrete elements, discrete group of elements. Okay, so you can never have anything like infinite anything or infinite values. Infinite values can never be there in anything, whether you talk about arrays in any other programming languages, whether you talk about numpy arrays in Python, or lists or tuples or dictionaries or sets, they will always be finite number of elements in them. Okay, just for this reason, when we divide anything by 0 using a calculator, it gives us an E, that is error. Why? Because it doesn't recognize infinity. Understood? Okay. So I already told you how to create tuples from existing sequences, that is from lists and from strings, right? Okay, so our time is up. So with this, I end today's class. So thank you everyone.